Hey everyone, I hope you're all doing well and thanks for tuning into another tutorial. Today's video will be an extension of the uploading files to S3 video I made previously, and as the title suggests, we'll be building a complete CRUD API that connects to an S3 bucket using API Gateway and AWS Lambda. Of course, we'll also be using the serverless framework as well as GitHub Actions for our deployment pipeline. But before we begin, I just wanted to thank the person in the comments for suggesting this idea, and more generally, if you have any ideas or suggestions or something you want to see, always feel free to drop a comment below. But for now, let's get started. Now, the first thing we'll be doing is setting up the deployment configuration, and some of this may be repeated, so if you watched some of my previous videos, feel free to skip right ahead. Now, in order to set up our deployment pipeline, we'll first need to obtain the programmatic access keys from AWS. So to do so, we're going to head over to the IAM management console, and we're going to go ahead and click users, and we're going to add a new user. I'm just going to name this S3 CRUD user. Feel free to name it however you wish. And we're going to go ahead and check off programmatic access. We're going to click next permissions, and then we're going to attach existing policies directly. Now, the list of policies that we need to attach are as follows. And the first one is IAM full access, as this will give us IAM permissions for our deployment pipeline. We will also need S3 full access for this project, so we'll check that off as well. And we also need API gateway, administrator, as well as push to CloudWatch logs access, so we'll check those off. And we also need CloudFormation, since this helps us deploy our serverless application. And last but not least, we need Lambda full access. Let me just type that. Oops. Lambda full access. Awesome. Okay, so once those are all checked off, we're going to go click next tags. We don't need any tags, so we'll click review. And once everything looks good, we'll go ahead and create our user. And now we will be presented with these keys, and this is the only time we'll have access to the secret access key, so we'll make sure to make note of it. So we'll copy that over, and we're going to go ahead and head over to our repository and click settings and add these as repository secrets. And we're going to click new repository secret, and we're going to click secret access key and add this. And the next one will be the access key ID, so we'll copy that over. Just make sure you don't get the extra space at the end, as I almost did. And we're going to name this AWS access key ID, and we're going to add this as well. And awesome, so once this is done, we can actually begin to write our GitHub Actions deployment file. And of course, to do so, we can head over to your editor. In this case, I'll just be using VS Code. And we're going to go ahead and create a new folder in the root directory called .github. And within that folder, we'll create another folder called workflows. This is just the way that GitHub Actions works. And within this directory, we'll create a file called main.yaml. And the reason why I'm naming it main.yaml is because I'm going to, this job is only going to be triggered on the main branch. And I've actually already set up everything, written everything out beforehand so as to save some time. I've gone over this a bit more in detail in one of my previous videos, so feel free to check that out. But basically, just to highlight what's going on, this part is specifying that we will only deploy our serverless application when we push to the main branch. And this part actually specifies the job and the corresponding steps. Essentially, we're using Node 12.x, sorry. And we'll also be installing the dependencies. And the main part here is this part. We're using the serverless GitHub Action, which basically allows us to deploy our serverless application to the AWS cloud. So we're going to go ahead and save that and leave that as is. Now, the next step we want to do is actually write out the serverless.yaml file. And to do so, we'll go ahead and go in the root directory, and we're going to create a file called serverless.yaml. And we're going to go ahead and actually name this project. So the first thing we want to specify is the service, and this is, we'll just call it S3 file API because that's pretty much what it is. We'll also specify the provider, and this is essentially the cloud provider. In this case, we'll be using AWS, so that will be the name. And all our Lambda functions will be using Node.js 12.x, as that is the latest version currently supported of Node on AWS. And we'll also just write a stage, and this is just pretty much telling you the environment of which your service is currently in. And we're in development stage, so we'll just leave it as that. And we also want to specify the region. And this is basically the region of which your service will be most closely deployed to. And generally, you want this to be the region or the data center that is closest to the users that you're trying to serve. So we'll just click US West 1 here. It doesn't really matter in this tutorial. The next field we also want to specify is the API name. Since we've already written that here, we can just reference the service variable by doing $curly brace self::service. And so that will reference that dynamically. And because all our Lambda functions, I don't think they will be highly intensive unless you're uploading a really large file or something. We can just keep them all as this using the same memory size and timeout. So we'll specify this as a global field. We'll just use 128 megabytes. And we'll also use a timeout of 10, and this is going to be in seconds. So feel free to play around with that depending on the types of files that you're going to be working with. Another field that we want to write or specify is an environment variable. So we'll do environment : and we're going to call this file upload bucket name. So of course, this isn't going to be a secret or anything. It'll just help our Lambda functions to be able to easily access the bucket name that we'll be basically working with. So to do that, we'll actually create a custom variable soon on, immediately after this, but we'll just reference it first. So it'll be custom dot file bucket name, and just bear with me here. Now we'll actually initialize that variable. So we're gonna go ahead and create this custom field and create the variable called file bucket name. And because I haven't created the bucket yet, we'll do that in a second. I'm just going to pre-name it here, and I'm going to call it S3 file bucket. And I'm also going to include the stage at which it's in. So basically, you're going to have multiple buckets depending on your development stage. In this case, it will be named like S3 file bucket dev. But yeah, you kind of get the idea. So we'll leave it as that. And now we can actually go ahead and write the configuration for the actual bucket. So to do so, we actually want to specify this under a field called resources. And the first one is going to be lowercase. And immediately afterwards, we want to specify another field, which is uppercase, but also called resources. It's a bit funny, but that's just the way it is. So we'll leave it like that. And we'll just call this thing file bucket. And of course, the type of this resource is going to be an AWS S3 bucket. And as for properties, depending on your use case, you should definitely feel free to experiment or look at the documentation to review the full set of properties that you can specify. But the one main mandatory one that we need is the bucket name. And because we have already specified the custom variable called file bucket name here, which stores our S3 bucket name, we can reference that directly, which is really convenient. So we're going to go ahead and do that, file bucket name. And of course, please do note that S3 file bucket names must be globally unique. So if your S3 bucket coincides or matches the same name as any other bucket in the world, or yes, I believe it's in the world, that will cause your deployment to fail. So make sure you choose a globally unique name. So hopefully nobody's taken this name so far. But yeah, and one last thing we want to do is actually just for general good practice is to keep the access control field as private. And this makes sure our bucket, everything in our bucket is kept private. And yeah, so that pretty much wraps up the section for setting up the serverless file in terms of deploying the S3 bucket. Now we can actually go ahead and write the configuration for deploying each individual Lambda function as well as its API gateway triggers. So in order to specify our Lambda functions, we're going to go ahead and write this under the functions field. And we're going to call our first function the S3 file uploader maybe. Oops, spelled that wrong. And this will basically be our post endpoint, as this will help us upload files. And we'll just write where the handler is going to be stored. And because I haven't written out yet, I'm just going to specify the path beforehand. And I'm going to name the file upload.js, and the function is always going to be handler, since this will be our Lambda handler. Feel free to name it however you wish. This is just a convention that I currently prefer. And of course, we want to name this file, and this will be our S3 file uploader. And you can also include a description. For the sake of time, I'll leave that out. But in the source code below, I'll make sure to, in the description below, I'll make sure to include that in as well. And anyway, so the main part that we want to specify for this Lambda function, or all of our Lambda functions in this video actually, is the event trigger. And this is basically the API gateway trigger that will actually allow our Lambda function to execute. And the trigger that we want to listen to is HTTP, as we'll be listening to those types of requests. And the path of this endpoint, you can specify this however you wish. This will perhaps be like your REST resource that you want. I'm just going to name this file. And of course, we also need to specify the HTTP verb or method. And this, because we're uploading files here, this will be a post endpoint. And that's pretty much it for setting up the API gateway trigger. We also want to specify IAM role statements. And basically, this field allows us to specify permissions for our Lambda function so that like as to what the Lambda function can access in terms of other AWS resources. And the default behavior of the serverless framework is to put this field under the global provider block, which applies to all Lambdas. But that's generally not considered a good practice, as we want to assign granular level of permissions for each individual function, as it's generally just more secure and offers you more control. And so to do that, to do what we've done here, we actually need to install a plugin. And this will be we can reference this under the plugins field. So we'll specify a new field here called plugins, and we're going to call this the serverless IAM roles per function plugin. And so before we move any further, we actually need to install this plugin as a global, sorry, not global, as a production dependency. So we'll type that out, serverless IAM roles per function. And once that is done, we can go ahead and actually specify IAM role statements per function. And this will come in really handy, as we'll see that each function has a different set of IAM role statements. But yeah, so we'll continue on, and we're going to go ahead and write our first IAM role statement, and that will be starting off with an effect, and we are essentially going to allow our Lambda function to perform this action, and the action will be allowing our Lambda function to add things onto the S3 bucket. So we can just do put, and there's a bunch of operations. I believe the main one we want is put object. I can't spell put object, but for the sake of keeping things a little bit less granular or just simple, we'll just include an asterisk, which is just a wildcard which matches put any types of operations with this prefix. So we'll leave it like that. And of course, we also need to specify the resource of which we want to apply this effect or this permission. And of course, this needs to be an ARN or Amazon Resource Name, I believe. And we're going to match it as follows. This is the current prefix for all S3 buckets, so we'll leave it like that. And because we have already created a custom variable for our file bucket name, we can reference it as such. And just make sure to include a slash with an asterisk at the end so as to match any nested directories inside your S3 bucket as well. And that is pretty much it for the S3 file uploader or the post endpoint. And we won't actually be writing a Lambda handler for the put endpoint, or basically handling the update portion of CRUD operations. And the reason for that is that by default, without enabling versioning on the S3 bucket, any uploads of files with the same name will essentially update or overwrite the existing file on the bucket. So to handle updates or put operations in your application, we can just call the post endpoint a second time and re-upload the file under the same name. And this will essentially upload the existing thing in the S3 bucket. So yeah, we'll leave it like that. Now we can actually move on to writing the get endpoint as well as the delete operation. So we can actually copy the post endpoint configuration, as it'll be really similar. And we'll just copy this twice and make sure our indents are all aligned. And we're going to go ahead and rename some things. So instead of file uploader, we'll call this S3 file get. This can just be file get, and make sure to change the file name. And we also want to change the HTTP method as well. And of course, we also want to change the IAM role permissions as well to get. And yeah, that looks good. And we also want to change the delete one to delete. So we'll leave it like that. Delete and S3 file delete, and of course the method should also be delete, and of course the method can also be in lowercase, but for legibility purposes, let's just keep it as uppercase. And one thing we want to be careful here is that the action that we want to specify is not delete asterisk, and the reason for that is because there's actually an operation called delete bucket, and we obviously don't want to give our Lambda permission to delete the bucket. Maybe you do, but that might be the use case for another Lambda perhaps. In this case, we only want to delete things in the bucket, so we'll actually be more specific and granular and call this S3 delete object specifically. And yeah, that pretty much wraps up that. One small thing we want to handle is allow our get and delete endpoints to actually specify what file we want to delete under what a certain path into the S3 bucket. And to do so, a good way to do this is basically to use path parameters. And to do so, we can specify as such by using slash and specify your path parameter key under curly braces. I'm just going to call this file key, and this is essentially the key into the S3 bucket of which we want to delete. So yeah, we want to do a similar thing for our delete endpoint as well. So we'll just do write that. Oops, and yeah. And before we just wrap up this section, we're going to go ahead and actually just create our git ignore file so as to not deploy our entire node modules, because that's just a huge folder and we definitely don't want that in our repository. So that should handle that. Okay, awesome. And yeah, that pretty much wraps up this section about setting up the serverless configuration file to not only deploy our actual S3 bucket itself, but also set up all our Lambda functions as well as their API gateway triggers. And yeah, so now we can actually go ahead and begin to write our Lambda functions. And because we've already specified that all our Lambda functions will be under the source folder, we're going to create a folder called source, and we're going to go ahead and implement the upload file first, or the Lambda handler. And we've actually already pre-implemented this from my previous video. I'll drop a link down in the description. So if you want a more detailed explanation of what's going on, feel free to reference that as well. And basically, just to highlight, we're using Lambda proxy integration. So that's basically what this comment is telling you. And basically, we want to stringify the response body to match that specification. And yeah, that's pretty much it. But right now, the current code for this only handles, or is meant to handle images and upload them as base64. But of course, if you want to generalize it, it should just be some minor tweaks. For example, like changing the content type to perhaps like handle PDFs or whatever other types of files you wish to upload. So we'll leave it like that. And we're going to go ahead and move on to handling the get endpoint. So we're going to go ahead and write get.js because that's what we specified here as our file name. And we're going to do a really similar thing and basically just begin by importing the AWS SDK. And I know I haven't actually installed it yet, so we'll do that in a second. But we'll just require it for now. And we're going to actually initialize the S3 SDK so that we can have access to their corresponding functions. So yeah, we're done that. Now we can actually begin to reference or retrieve the environment variable that stores our bucket name. So I'm going to call this bucket name, and it's going to be under process.m.file upload bucket name. Awesome. And of course, we want to set up the framework for our Lambda handler, which the function is actually called handler, as we have specified. And it's going to be an asynchronous function that takes in one parameter, which is the event. This is just going to be a giant JSON argument. And yeah, awesome. So now we've set up the framework. I'm not sure why I have to switch the tabs every time. Something's wrong with my editor today, so bear with me there. Anyway, so one of the good practices to do when writing your Lambda handlers for debugging purposes or whatnot is to basically just log the event. It helps you see what's going on and what's actually coming into your Lambda function. And after that, one thing we want to do is actually initialize this response variable. And essentially what this is the actual response object that will be returned from your endpoint. And you will see in a second when we test this that we can actually see what's coming out. And because we're using Lambda proxy integration, one field that we need to specify is whether the response is base64 encoded, and this part is not, so we're going to write false here. And we also need the status code. And just as a happy case, we'll keep it as 200 for now. We can modify it in our try catch statement right now. So just setting up the framework for the try catch. Awesome. So in the try block, what we want to do before we actually try to retrieve the S3 file under a certain key is to actually specify the parameters. And this object will include the bucket name, so we can reference it as that. And we also want to include the key. And now because the key is going to be passed under as a path parameter, as we have specified here, we actually need to retrieve that. And that field is going to be under event.path parameters. And we don't need to JSON parse this or anything. It's already parsed for us. So event.path parameters, and it's going to be called file key, as we have specified. And because the way that S3, essentially S3 directories within the bucket works, is that sometimes you might have a path, for example, I'm just going to note here, you might have a path like images / I don't know, image1.png or something like that. For example, this is your path, right? And this is essentially saying that your image1.png file is under the images sort of like directory inside your S3 folder. And because this is going to be passed as a path parameter, this / here needs to be URI encoded. So it's actually going to need to come in as %2f, I believe, is the URI encoding for a slash. So, and because we want to do that, we must then actually decode this in our Lambda function. So we're going to do decode URI component and pass in the file key into this function. And that should give us the correct key when we actually try to retrieve the file. So yeah, that's our parameters. Now we can actually just perform the retrieval, and it's quite simple. We just call an await s3.delete object. Oops, sorry, not delete object. I was getting ahead of myself there. Getting much ahead of myself. I apologize for that. It should be get result, and we're going to go ahead and, of course, await for that function call. This, I believe, is get object, and we're going to pass in the parameters. And of course, we want to await on a promise, so we're going to do dot promise. And yeah, so now we want to modify the response body, I guess, just for good practice, and make sure that it's a stringified JSON for Lambda proxy integrations. And we can just include a quick message saying successfully, if I can type today, successfully retrieve file from S3. And we can just include the get result as well. For debugging purposes, feel free to just remove it if you wish. And for the catch block, we can just log the error for CloudWatch logs. And we can also include it in our response body. Again, we need to make sure that we stringify this. So the message can just say, failed to get file. Yeah. And of course, we also want to include the error message in our response body as well. And this is the case where the setting the status code becomes a bit useful, because when the Lambda fails, we obviously want to change the status code. I'm just going to use 500 here, not 5,000. But feel free to make it more specific to your use case as well. And of course, last but not least, we definitely want to return the response. And yeah, this is pretty much the implementation for retrieving your file from the S3 bucket. Now we can go ahead and move on to writing the file for deleting the S3 objects. So to handle our delete file, it's actually going to be really similar. We're just going to create a new file called delete.js, and the handler is going to be really similar to our get.js file. And we just copy most of this over and paste this over here, and just make sure a couple of things that we need to change here. Everything else is going to be similar. We're going to decode the URI component, which is going to hold the file key of which we want to delete at. And of course, we want to specify you use the delete object function instead of a get object. And I guess this is going to be delete object. So we'll just include that in our message as well. And we'll change successfully the log message as well. Successfully deleted file from S3, failed to delete. And awesome, that is pretty much it for the delete object, the delete endpoint Lambda handler. As you can see, it's really simple. Most of it is duplicate code from the get endpoint, so feel free to refactor it if you wish, just for keeping things nice and clean. I realize I made a small nitpicky detail. I'm just going to quickly edit it on screen, but I'm going to name this data because get result doesn't sound really good. After all, it is the data that we will be retrieving anyway, so I'm going to leave it like that. And yeah, that's pretty much all our Lambda implementations for all the CRUD operations. Once again, the post and the put share the same Lambda, essentially for S3 at least. Post and put are the same thing pretty much here. So we only have one Lambda function for that, and that's upload.js. We also have the get.js file for our Lambda handler for the get endpoint. And of course, we also have the delete.js file for our delete endpoint. And yeah, now we can actually finally try to deploy this, and hopefully everything works. But for now, we'll be right back once everything is deployed. So we're back, and I realized I forgot earlier to actually mention that we need to explicitly add the production dependency of the AWS SDK. So just type in this command and we should have it installed. I've already done that. So let's just head right over to our deployment. So if we take a look here, we can see that our deployment actually succeeded here. And if we take a look at S3, we can see this is our bucket name, and it's currently empty, as expected. And what I want to show you right now, in order to test our actual endpoints, is that we can actually head over to API Gateway, and we can get the base URL, so we can actually call these endpoints. So once that's loaded, we can click into our API. And then we can head over to stages and click onto dev. And I guess we can just start off with by by adding some images. And so I'm going to copy this. This will basically be our endpoint that we'll call. And I'm going to be using Postman, which is a handy tool that I'm more familiar with, but there are other options as well. But basically, this allows us to call this endpoint. And right now, I've attached a file. This is just a preloaded base64 image that I've generated. And I'm just specifying the file key here. This is just how the Lambda is currently written, but feel free to tweak it to however you wish to specify, like, for example, the key of which you want to upload the file into. So this basically means I'm uploading into a folder called images, and if it doesn't exist, it will automatically create it for you. And then under that file folder, I'll attach this file and I'll label it file1.png. So we're going to go ahead and click send, and hopefully this all works out. You can also monitor CloudWatch logs to see any logs that you have included, but for this tutorial, we'll just keep it simple since that's kind of covered in my other videos as well, so feel free to take a look at that. But anyway, yeah, we'll just keep it simple. As you can see here, it has been successfully uploaded. It took a while because the image is kind of big, but yeah, let's head over to S3 and just to see if it worked. And as you can see here, the images folder is created for us, and we get the file1.png. And now we can go ahead and test our get endpoint. So of course, let me just copy this over. The endpoint is going to be the same, and we're just going to use get here. We don't need any request body, but we do need the file key. And it's important to note that this key needs to be the full path of the file. So if you know where it is, then that's convenient. Generally, you would store this in perhaps like a database or something that references your file paths, and then you will call this API to actually get the data. But anyway, since we already know where it is, we're gonna type it out. So to do so, we're going to type images, and of course, we have to remember that we actually need to encode the URI component. So once this is encoded, the slash will turn into a %2f. And of course, this can also be lowercase f. I'm just going to keep it as uppercase, and that's a slash. And then we also need file1.png. So if we go ahead and click send and try to retrieve this image, it will come back as binary data, I believe. Yes, and as you can see here, it's taking a while to parse because it's really big. But basically, we've successfully retrieved it. And if you recall, I put everything under this data field. Sorry, this data field, yes. And this is the entire data object. And basically it gives you things like such some metadata like the content type and whatnot. And the key area of which the data is stored is under this field, the body field. And this is essentially a giant JavaScript typed array, I believe, of binary data. And you can treat this as a buffer, I believe. But anyhow, the point of the tutorial is to keep things flexible. So you can, depending on your application purposes, you can feel free to modify this or work with this or stream it however you wish. But basically, this is like a basic implementation of how you can actually retrieve data from your S3 bucket. So yeah, that's the get endpoint. And just to showcase for completion purposes, let's demonstrate how the delete endpoint works. So we're going to select delete, and the endpoint and the API base URL of the API is going to be the same. We have the file key as the path parameter. We don't need any request body or anything like that. And we can hit, actually, let's just showcase that the object is still here. So yeah, as you can see, it's still there. And we're going to hit send, and momentarily the object should be deleted. And we get a successful message. And as you can see, the object is gone. And there you have it. That pretty much wraps up this entire tutorial for how to build a CRUD API using API Gateway and AWS Lambda that is connected to Amazon S3. And of course, if you learned something or found this video helpful, please do consider hitting that like and subscribe button down below, as it really helps out the channel and series. And if you have any other content or tutorials that you'd like to see, feel free to leave comments below as well. And as always, I hope you're all staying happy and well out there. But for now, I'll see you in the next video.